Are we ready to go?
Yes.
Okay, we're going to go. Hey everybody, I'm Jacob here, and I'm going to talk about a duck in the hand is worth two in the cloud, and how we do data preparation analytics with DuckDB. So quick set of intros here. I'm Jacob. I work in DevRel at MotherDuck, and I'll also have my colleague Gwen come up here in a little bit and do a demo for us. So it's going to be a lot of fun. She's a software engineer. So I think what I want to do to start here is really just talk about how we got to where we did today. And this is kind of the big data story. If you look at this dot, this is around 2005. And our friends at Google did us all a big favor and started writing about the problems they were running into, like Google File System, like MapReduce, like Bigtable. And something that was happening at this time is if you look at this trend, I don't think we even need like a linear regression. We can just do this, right? This is clock frequency. There were certain assumptions made about architecture around this time that led to design decisions made in the software that was produced to handle big data. And what happened is the trend actually didn't hold. Our CPU frequency was flat. So what we did instead, in order to hold up Moore's law, is we started scaling the number of cores. Also around that same point in time that CPU frequency kind of flattened out. And so now we have logical cores increasing. Again, Moore's law continues to stay true, kind of in a strange way, a way that we've never seen before. At the same time, storage got a lot cheaper. From 2005 to today, it went down in price from $2 per gigabyte to a cent, and if some colleagues at AWS are to be believed, the actual price per gigabyte realized there is much, much lower than this price. So we also have this happening too, which is storage getting faster. Okay, so what this means is things that used to take a lot of time and need to run on a bunch of nodes because we need to run a bunch of hard drives in parallel can now just run on a single hard drive. And as it turns out, that means we built really big nodes. I pulled this off Vantage SH the other day. This is the biggest nodes available in AWS today. I think they're actually were first built to run SAP HANA, which is coincidentally in-memory analytics. Yeah, we have like 32 terabytes of RAM and almost 900 vCPUs on these things. So like pretty big single nodes. So we have an observation here, right? Number of cores goes way up, storage price goes way down. If you know these things are true, or you notice these things being true, what kind of software would you build, right? You probably wouldn't build software that needed to run on a bunch of nodes. So I'm going to introduce DuckDB. So this is a single node in process OLAP query engine. It's very efficient. It has a lot of innovation placed in the way that it automatically multi-threads. So what this means really is that you can saturate your node with a single query. For those of you that are familiar kind of with database primitives, that's actually really hard to do with like Postgres or SQL Server. By design, by the way, you want space for transactions. DuckDB saturates on a single query. It also has some really nice features and support around reading files in a bunch of different places, in a bunch of different formats, geospatial, data frames. I know it's kind of come up in a few other talks, so I won't go into too much detail, but there's some really nice ergonomics there. And again, it's all in SQL. So no switching languages, write a SQL, you can select star out of an S3 bucket, for example. So what we're doing at MotherDuck is rethinking what data warehousing workloads look like for the real data workloads that you have. There's no distributed overhead. We are aggressively single node. Because of that, we find it easier to accelerate business value because we can tie across all of the parts of the kind of problem stack in SQL. And of course, because it's powered by DuckDB, we get all of the fun stuff that they nerd snipe each other on. So what does this mean for us? I stole this from a slide that Hannes, the founder of DuckDB, put together at POSIT conference earlier this year, which is we are approaching the data singularity. Our hardware now exceeds the amount of data that we can produce on a daily basis. So we have reached the data singularity. That's where we are at. And so from here, we're going to jump into a demo that Gwen is going to take us through.
Cool, thank you, Jacob. All right, so if you want to code along with us or look at this later, this is the URL we can find the code. So what I'm going to show you today is how to do a large data set, how to process a large data set on your laptop. So you're probably familiar with pandas, right? So if your pandas data frame is like 10 megabytes or something, it's really well behaved. It's very nice, actually very expressive, beautiful. It works great. But once you get to like 10 gigs above, things start to get a little awkward. You know, it should work, it looks like it works, but it doesn't quite feel right. So that's what I call the uncanny valley of data. There's this kind of area kind of in between where you go from small data or tiny data to big data. It's kind of like, you know, it's not quite clear what tool to use. So as Jacob mentioned, computers have gotten more and more powerful. Single nodes are actually quite performant. Most people have like a pretty powerful laptop with, you know, over 10 cores and, you know, 30 or more gigs of RAM. So, you know, why can't we do like 100 gigs or like 10 gigs like comfortably on a laptop? So I'll show you a data set that is procured by the Cornell Lab of Ornithology. You know, any birders? Any birders? Yes, birders. All right. So there's an app called Merlin that you can download. If you see a bird in the wild, you can identify it and log it, and it's going to end up in this database. So you can download it. It's called eBird. It's a citizen science project, so everything is available. You just have to sign. You know, you're not going to use it to, you know, hunt rare birds, you know, in front of location, like the breeding location. You're supposed to, you know, use it for personal use. So if you're interested, you can actually just go and download it right now. It's about 160 gigs of compressed data, .txt.gz file. So what I did is I downloaded that file, and I'm going to show you now how to do some filtering and prep, like on my laptop, without having to, you know, go to like a cluster or a large, expensive data warehouse or Postgres installation somewhere. And then I'm going to do some interactive prepping and pulling it into a data frame, turning it into a nice small data frame that I can visualize. So just all you need to run this demo is DuckDB. I lied, of course you need Plotly too. There are a few other, but to wrangle the data, all you need is DuckDB. The way you connect to a DuckDB file is like this, duckdb.connect, and then you put the path of your file. So it's similar to SQLite, you just connect to a local database. If you want to connect to MotherDuck, which is the cloud version of DuckDB, you can actually use this MotherDuck MD : connection string. So I'm going to show you that right now here. Let me just see, is the font size okay for everybody? Yes? All right. So, just full screen this. So what I did is I downloaded this file. When you go to ebird.org and you download the data, it gives you a .tar archive file. So I unarchived this and it turns into this txt.gz file. It took me about 5 hours to download this. This was just like on a pretty fast internet connection. And then I loaded it into MotherDuck. So what I did here is I ran DuckDB just in the command line. This is all just, I did this before the workshop. I'm not going to show this live because this takes about an hour. So that's one thing you need to know about databases, right? So once you've loaded your data into the database, all the queries after that are going to be super fast. So this is an initial load step you're going to need to do. So what I did here is I just did what we call a C task, create table as EBD. That's what this database is called, the eBird data. And then I took a subset of some of the columns in there. So there's a global unique identifier, which is kind of like if a person submits an observation in Merlin, for example, the common name of the bird, the scientific name of the bird, subspecies information. And then here I'm doing a little bit of data, a light data cleanup. So those of you who are data engineers, you know that this is never what it looks like. There's lots more cleanup to do usually on your data. But you know, we're lucky here that eBird has done a lot of that work for us. But observation count, sometimes it has an X and sometimes it has a number in it. Because it's a TXT file, right? There's no type checking. So now I'm loading into a database. I'm actually going to cast this to an integer. If it's an X, I'm going to say, okay, there's 0 birds, 0 observation. Then I'm going to get the country and latitude and longitude, which is going to use for my visualization, and the observation date. Then DuckDB has, like what Jacob mentioned, DuckDB has some really, really amazing ergonomics for reading different types of files. So there's this function called read CSV, which I can use to directly read this compressed TXT file. So I actually, I was getting ready to start like unzipping this and be like, okay, do I have enough space, on my hard drive? I actually don't have to do that. I can just read it directly from the file. And it's actually faster too. So that's very convenient. Okay, so I did this, take about an hour. Now it's all in MotherDuck. So MotherDuck, all you need to connect to MotherDuck is a MotherDuck token. You can get that from the app. If you go to app.motherduck.com/settings, it lets you create a token. You can set the lifetime of the token. You can have it expire in a day, expire in a year, never expire, up to you. If you use it from Python, typically what I do is that I create an environment variable called MotherDuck token. I use a library called .m for that. So I just create a file. It's called .env. In there, I literally put this text MotherDuck token equals, and then I paste the token there. You can also, if you're on Windows, you can like export it to your environment variables before you start Jupyter. But yeah, those of you are familiar with how that works. So, okay, so now I'm going to go ahead and connect to MotherDuck. So I import DuckDB, and then again, like the previous slide, all I need to do is connect to MotherDuck.ebird. So I already created that database, so that's what I did here actually. So let me just here create database ebird. That's what I ran before. Forgot to add that. And then that's my data, so I'm going to connect to that. So now for this demo in particular, I created this connection wrapper. There are a lot of people who are usually only in the Python ecosystem who are not super familiar with SQL. So I'm going to just basically show you some nice convenience functions. But actually, I'm much curious of a show of hands. Who are you are pretty comfortable with SQL, use it in your day-to-day job? Okay, that's actually most people here. Who of you mostly use like data frame libraries like pandas, polars? Okay, great. So there's actually a lot of SQL experts here. So that's okay. So I just created a query here under tables. I can actually just show you what it does. Here is just select database schema name from show all tables. And that is just running under the data. So I'm seeing what database I'm in, what the name is, and then I made another a convenience function called describe. So what that calls is it just calls describe EBD. It gives me, so I can also just, now that I know everybody knows SQL here, I can just do this, same thing. Easy peasy. There's also a really nice Jupyter magic command you can use. It's called magic-duckdb. So then you type %DQL, and then you can start typing SQL directly in Jupyter. So here are all those columns I loaded. So yeah, all the types look good, great. So let's actually see how big this data set is, because I know it's like 160 gigs, right? So let's just do a count star. So here I'm using the DuckDB relational API. That's all built in. Looks like it's about 1.7 billion rows. So that's a lot of bird observations, and that's from all of history for the entire planet, right? Okay, so now typically what I do now, I want to kind of see an example of the table. So let's get a subset of some of the columns here. So okay, there's a lot of cute bird names out. Who here plays Wingspan board game? Yes. Okay, you're my people. Yeah, this is fun. There's so many birds. There's 10,000 birds in here. They've all got cute names. So basically what you can see, so there's United Kingdom, Colombia, we've got 2024, and it keeps going. So okay, now I kind of know what the shape of the data is. So let's start. So Jacob and I live in Seattle. That's where our HQ is, MotherDuck. And there's a lot of birds in Washington State. And sometimes I look up and I'm like, hey, what is this bird? So I'm just going to use this database and see what are the 5 most frequently observed bird species in Washington State. So for this, I'm going to use the PySpark API. Again, if you're comfortable with SQL, you can just run a SQL query here. The PySpark API is under duckdb.experimental, and it lets you use a data frame library, like language. So again, I create a data frame. I pass in the relational expression for the EBD table here to create like a Spark wrapper data frame, and then I can do this kind of chained, like .filter, .groupby, .ag, etc. And I'm going to first filter, I'm just going to see it for last year, because all of time, I'm not super interested in that, and it's going to be slow as well. We see United States, State, Washington. I want to group by the common name, and then I want to get the sum of the observation count. And I want to just take the top 5. And here we go. So the most commonly observed bird in Washington State is the snow goose. All right, so those are those kind of white geese that honk and fly in groups, or flocks. So this is very handy. So hey, there's another cool thing that we support on Mother Duck, and that is natural language to SQL translation. So I've made this convenience function called prompt query, which you can see here what it does. It just runs pragma prompt query. So again, it's a very, very simple SQL command that I can run, and then I can pass a sentence here. Say, get me the top 5 common names and total observation count of birds in Washington State in 2023. It's going to be a little bit slower than just writing the pure SQL, because it needs to actually call the language model. But yeah, under the hood, so this prompt SQL convenience method, it uses the prompt query or prompt SQL function, table function, and it lets me actually inspect what is the SQL that's being generated. So this is more or less what I can write this myself, right? But if you have more, or if you have users or colleagues in your space that are not the most comfortable with SQL, this is a really nice tool to be able to offer them, right? Okay, so now I know it's a snow goose, so let's look at all the observations of snow geese last year sorted by month. So again, here's my query. I'm again using the Spark data frame API, but again, use whatever you're comfortable with. I'm going to filter by the observation day being last year, and then for the snow goose, that's the common name. And then I'm going to now create a new column called month. I'm going to alias that as month, because I want to see month by month where these birds have been migrating. So I'm going to run this. Oh, it's already done. So that's one thing that Jacob told me, is when he used DuckDB for the first time, he couldn't believe it was so fast. He was like, did actually my query actually run? So I was just like, I just had the same experience. So it's 14 milliseconds, right? And this is on this giant 1.7 billion row data set. That's pretty cool, right? My laptop is not even sweating. This is all running in the cloud, DuckDB in Mother Duck. Okay, now I'm going to store this in a temp table. So temp tables are a feature in DuckDB. They are basically the same as creating a table in your memory data, in your in-memory database, but it's just like a convenient shorthand. Let me again just let you peek under the curtain here to show you what is the actual tier 2 temp table. It just runs a create or replace temp table. Okay, it's a little bit hard to see. I'm just going to type in here, markdown, because it's easier. So it's create or replace temp table bird obs as, and then here I put my query, right? So I'm going to do that, and I can here, because it's a Python relational API, I can just pass that relation in here. So I created a relation here, so that's what the PySpark experimental API does. It just creates a result which I can get the actual relation. So I just run this relation here. That's going to give me back that table. There you go. So this is a kind of a lazy loaded preview of the data. So I can inspect. So like, does everything look good? And anyway, I'm going to go and create that temp table now. And I'm going to go and inspect that. So again, con.table, again, is the relational API. It's going to give me a lazy preview. So again, so these are all the snow geese, all the observations in the entire world in the last year. And then I'm going to see how many rows is that. So that's pretty reasonable, right? It's like 100,000 rows. It's comfortable. So now I'm going to go and visualize these results. I'm going to use the H3 library. So if you're familiar with geospatial data, H3 is a library created by, or like a standard created by Uber. It divides the world map into hexagons. I could pick what kind of resolution I want to use. So high is very fine, so very small hexagons, and 0 is very large and coarse. So I'm going to use 6 because that's sort of the right resolution that I want. And I'm going to go and downsample my data just so my plot is a little bit faster, right? Because I'm going to use Plotly, and every single point is going to have some amplitude, and it's going to do a lot of computation here in the browser with JavaScript. So what I'm doing here is I'm converting the latitude and longitude to a cell ID, which is, again, it's splitting up the world into hexagons with this number 6, which is like, seems arbitrary, but yeah, that's the resolution I'm using. And then I'm going to convert that back into latitude and longitude. And now I'm going to go and plot that. So this is like, again, this is a very well-behaved happy pandas data frame. And I go plot that. And here we go. So these are all the snow geese. Zoom out again a little bit. I made a little animation here, so it will go by month. So as you can see now, snow geese migrating up north in the summer, and they're now coming back. So yeah, this is pretty cool, right? This is just from people, open data set, people in the US just seeing a snow goose and being like, hey, I'm gonna put that in eBird. So thanks to those folks, birders, for your service. All right, so the next thing I'm gonna do is, I think this is pretty cool, right? I can see the geese like moving. I'm gonna see if there are any other birds in the eBird database that travel further distances. Let's look at some birds that mostly spent their time in Mexico during the winter and in Canada during the summer. So I'm gonna be lazy and I'm just gonna go ask my AI model to generate SQL for me. Okay, it's the semi-palmated sandpiper. Okay, sounds like a really cute bird. I think it's here. Yeah, Cornell, ornithology department has it. So this is the bird. Looks very little, but it's mighty. I'm going to go, and I created the function get observation, which just runs everything that I just showed you. It filters down the data. It gets all the bird observations for this particular species in this year. And then I'm going to go and plot it on my OpenStreetMap again. There we go. So in the winter, they're all in South America. So let's run my little animation again. And there we go. They go all the way up to the north, and then they come back down. And now let's see, because I'm not an ornithologist, so I know nothing. So I'm going to go look. And it's actually correct. They are indeed, they're hanging out here at the coasts in South America. Then they migrate through continental US up to the north of Canada where they go for breeding. So this is pretty cool. I'm gonna just look at it again because it's very satisfying. Okay. Birds. Okay, so lastly, we love ducks at Mother Duck and at DuckDB. We just love ducks. So one thing that Mother Duck also supports is a ChatGPT or GPT-4o model interface. So again, let me show you what that looks like in SQL. So it's just select prompt. So it is pure SQL that you can run to generate natural language. So I'm just going to ask, what is the scientific name for a duck? Actually, there are a lot of, here it says, depending on the specific species, duck refers to a broad group of waterfowl in the family. Anatidae, the mallard is very common. So hey, one interesting thing is LLMs have information in them. They're maybe not a database in the same sense that you can look things up. But hey, maybe we can do like a join on this data. Maybe we can use the data that's in the LLM, join it with our data from our database, and see if we can get something interesting. So here, I'm gonna do this. This is now our prompt, right? It's gonna say, give me the top 100 common names observation year for Washington State 2023 by total number of observations, then aggregate them into a single column in this form. So I'm going to just do column name and value, aggregate all the rows, and then prepend this prompt here. So I'm going to use natural language to SQL generation to create a query that's going to give me data. Then I'm going to go parse it back into a prompt, into a string, which I'm then going to feed back into my LLM, right? So here I'm using a combination of my text to SQL and my actual GPT model. So I'm going to run that. Again, this looks like last time I ran it took about 6 seconds, so definitely faster than I can create SQL. So here you go. So this is my prompt now, right? So here, user asked the following question: which top 10 duck species were observed most frequently? Please answer the question given the additional information. Here is the additional information. So this is coming from eBird, right? So eBird knows. I'm going to assume that ChatGPT was not trained on eBird, but now I'm giving it some info from eBird. Okay, so I'm going to go do that. So I'm using SQL here, right? I'm using a CTE. So with prompt text as that thing I just showed you, select, and then that prompt table function that we support in Mother Duck from prompt text, and then I'm going to just fetch the first result, and I'm going to print that to terminal. It takes about 5 seconds to run. And here we go. I have to admit, I actually did this without LLMs before, and it was a pain, right? Like I spent probably half a day, like grabbing like pages from Wikipedia about all the duck species in the world. It just took me like a lot of time, and this took me like 10 seconds. Like the LM already knows everything in Wikipedia almost. So instead of me having to create a whole new table with all these different duck species and then having to join that on the scientific name, and that was actually a big pain because there's apparently, I'm not an ornithologist, right? So please stop me if I'm wrong, but there's apparently multiple authorities with different opinions about what scientific names for ducks should be. So I had like 3 columns with different scientific names, and then I had to do a join on all 3 of those to make sure I didn't miss anything. It was a pain. This took me 10 seconds. Love it. Very excited about this. So yeah, so the American widgeon. So just for funsies, I'm gonna go see what is the migration behavior of that bird. I'm gonna use my that function I created. It took 1 second. Bam. Here we go. The American widgeon. Where is it going? Of course, it's going north, because that's where birds go. So. Or in the winter, sorry. Anyway, that's it. So that's the demo. I wanted to show you this. We're very excited about how you can use DuckDB and MotherDuck to interactively explore large data sets that don't quite fit on your laptop, but still use your laptop for computation. And congratulations, you are now holding a duck. That easy. Thanks all so much for your attention. Matson, you can reach out to us. Jacob and I are available on our MotherDuck community Slack, so please come chat with us. And we've got 10 minutes for questions.
Any questions?
I was just curious about how the like LLM Gen AI component worked. So I was just like taking a quick look at this, and like I guess it's like a plugin that you have for DuckDB and it's powered by something. But like I was curious, like did you do anything specific for DuckDB's SQL generation, or is it just kind of more just general SQL generation work pretty well? And like do you ever run into errors with the SQL generation?
So we didn't explain this, but MotherDuck works in any DuckDB environment. So wherever you can DuckDB, you can MotherDuck. So the way this works is DuckDB is a really beautiful framework for extensions. So we created an extension called MotherDuck that gets automatically installed and loaded in your DuckDB installation, your DuckDB database, when you connect to one of those MD : here, like this MD : and then, for example, my_DB is like your default database, but you get ideas. The prompts that I just showed you, which is, oh, snap. Yeah, Plotly sometimes crashes, sadly. Okay, so this here, all the way at the end, this select prompt, where did we go? Here. Oh, no, it is actually down here. Here. This is a table function, right? That gets loaded into your DuckDB instance when the MotherDuck extension loads, and it gets evaluated on the MotherDuck service. So we run a service that actually has our model running, and that evaluates that prompt. Now to answer your question about like, did you run into any challenges, right? Text to SQL. I think, Jacob, do you want to answer that question?
Yeah, sure, I can answer that question. So we actually do train a model that's available on Hugging Face for doing natural language to SQL. We're working on training actually the next version of that. We do keep benchmarks up there too. GPT-4 is marginally better than the model we've trained, as an example. So, but we trained it probably about a year ago. So we definitely do track that. We track that for accuracy. It's pretty good because it's trained specifically for SQL, specifically for our dialect of SQL. But obviously, I think our point of view is not that natural language to SQL replaces the analyst, is that it helps kind of bridge the gap in terms of problem solving. And so if you can help accelerate what you're thinking about as a business user with natural language, and then kind of partner with your data scientist or your data analyst team, we think that's a very strong pattern for helping kind of data teams scale. Yeah.
I'm just trying to understand a little bit better where the computation is happening or the data is in the demo. So did you upload the data to the cloud or to MotherDuck, and that's why it was fast?
Yeah, I'm going to repeat the question just for the.
Slide.
Could you repeat the question again?
Yeah, no, I can repeat it. So I think the question was like, where's the computation happening? Where's the data? And is that fair? Okay, great. Do you want to take that one, or do you want me to?
Yeah, go ahead.
Okay, so in this case, the answer is a little bit of both. So DuckDB, as we've implemented it with the MotherDuck extension, has dual execution. So there's some execution happening locally, some happening in the cloud. In this case, most of the data is in the cloud. The kind of first step that we did is we downloaded that data set, actually using an EC2 instance because it's so large and kind of slow download. And so we just did that, and then it's as simple as running that select query that Gwen showed to make it available in MotherDuck, right? Here, let me go. Can I switch over to that? So we'll go to the very top here. Okay, so this statement right here took that file that was on kind of an EC2 instance, and it put that into MotherDuck. So when we're running these queries, we can join kind of a combination of the cloud and local data. In this case, I think all the data was actually in the cloud because the prompt function runs in the cloud also. But it's returning. I mean, it's in this demo. It's effectively the DuckDB interaction piece is kind of like a thin client, and then the pandas data frame stuff is happening all locally.
So what basically what Jacob was saying, the first part is in the cloud. So this initial query here, where I just look at get all observations for a particular bird in a particular year, that's happening on MotherDuck. Then I pull that down, save it into a temporary local table, and then I do this post-processing where I do the downsampling for the plotting. So this is a really good question because it's so seamless, right? Like you don't even, like you just do con.sql and it's like, it's so seamless that you always don't know anymore what is running locally, what is in the cloud. But that's the power of our platform, is we make it very easy to go back and forth between cloud and local, and it basically does everything for you. It figures out for you what is faster to run locally and what is faster to run in the cloud.
We can take one more question.
Can you speak a little bit about the schema inference at the beginning?
Sure, yeah. Yeah, so this is a tabular file. It's a .txt file. It's basically a CSV, right? It just comes separated values. Yeah, it's automatically inferring the types here. I can read CSV, does take optional input arguments, so you can actually explicitly, does that work?
Yeah.
Yeah, you can explicitly specify what the types are, but yeah, in this particular file, I just inferred it automatically.
Okay, that was all. Thank you. That was fun.
Cool. Thank you.